Hey Pre-Algebra, we are jumping into a new chapter today. We're looking at chapter 11. We're only going to do 2 sections of chapter 11, and this is our first one. It's also pretty simple. This should be review. We need to get good at this. It's going to show up forever and always, no matter what kind of math you get into, this will always be there. So we have to be pretty good at this. We are not going to get into too much depth. You are going to learn one new thing you may not have seen before. Okay, so we're going to talk about square roots today. Who can remember what a square root is? Give me a second to think about that. Yeah, if you have a square, like if I took the number 9 and I said I'm going to have 9 squared, that means I have 9 times 2 and get 18? No, that means I have 9 2 different times. I have 2 factors of 9 and I'm going to multiply them together, which means I would get 81. So on my number line here, and I don't want you to see everything, so let me move it down here. The 9 squared could go right about here. I could write actually a 9 squared on my number line where I think about 81 would be. I could write 9 squared. Okay, now we're not going to do that right now because we have a different purpose for our number line. But not only could I have this number as an 81, but I could say it as 9 squared, right? Those are the exact same things. 2 different ways to write the very same number. There's an equivalence to it. Okay, so let's practice our squares. Let me see. These are some that I'm going to have you memorize and work on. In the future, you'll have to kind of memorize them for me at this point for COVID. I'm not sure there's an easy way to do that. So we're just going to practice them. So 1 squared would be 1. 1 times 1. 2 times 2 is 4. 3 times 3 is 9. What's next? 4 squared is, good, 16. Now, it will be helpful if you find a spot in your interactive notebook, I should have started with this, to write this whole thing down. When we are putting square roots in order, which we're going to get to in a minute, knowing your perfect squares is a really quick and easy way. Now, there is actually a list of these on page 451 in your book if you're looking there. Okay, 5 squared is 25, 6 squared is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9, we just did that one, 81, 10 times 10 is 100, 11 times 11 is 121. 12 times 12 is 144. Now, these are probably all ones you have memorized. I don't know if you have your 13s memorized. Your book gives everything up to 20. We are actually just going to go to 15 and also no 20. Some of the other ones are going to be good to identify, and you will have them in your book. But in terms of memorization, I think this is a sufficient list. Okay, 13 squared is 169, 14 squared is 196, 15 squared is 225, and 20 squared is 400. Now, I always say that a square root is like unsquaring something. All we've done so far is to square something. But what if I wanted to back up and undo what I just did? Well, if I took 400 and I took the square root of it, essentially what I'm saying is, hey, what number times itself is going to equal what's my radicand, or what's underneath my radical? In this case, it's 400. So what times itself gives me 400? Well, I know that 20 times 20 is 400. So the square root of 400 is equal to 20. Okay, you find whatever is multiplied twice, and you get rid of the radical symbol, and you keep one of them, essentially, right? Because 20 times 20 is 400. Okay. So any one of these numbers I could back up, and I could say the square root of 144 is equal to 12. The square root of 169 is equal to 13, etc. But what we need to remember is that if we have, now that we know our negatives and our exponents, we also have a couple other things that could be true here. So if I have negative 20 times a negative 20, negative times a negative is a positive, right? So I would still get 400. So if I unsquared 400, couldn't I also say that this is equal to negative 20? Now, we are not going to get into too much depth, and I'm not going to ask for you to write plus and minus, but I want you to be exposed to it. I want you to see it because this is coming in the future more. So technically, a better answer, now that we're getting into algebra, of the square root of 400 would be, we're going to write it this way, both plus and minus 20. And I shouldn't have written 200. Okay, plus and minus 20, because you could have a negative 20 times a negative 20 to get 400, or you could say 20 times 20 to get 400. Okay? All right, now I know I'm kind of going through this a little bit on the quicker side here. We are going to start by putting some of these onto our number line. Okay? Now, ignore what's in that yellow box. We are going to get to that in a minute. I just needed to put it there so I didn't forget. If we take the square root of every single one of these numbers that we put on here, we are also going to be able to find where they could be on the number line. Okay? I would suggest before you do your homework tonight to just make an entire number line, to do the whole thing. Write the whole thing out, put the square roots on there. But again, of course, you do not have to do that by any means, but that might be a good tool if you're struggling with this today. All right, if I took the square root of 1, what do I get? If I took the square root of this side, I should get what times itself gives me 1? Well, in this case, it's just 1. So right up here where there's a 1, I could also write, let's change this a little bit. At a 1, we could write the square root of 1, right? And if I took the square root of 4, I would just have 2. So right where there should be a 2, I could write the square root of 4. Do we see what's happening here? The square root of, this is not a great number line. I was thinking if we were to put the square roots on here, we could do that also. Well, let's just kind of stop and adjust our number line. This is going to get pretty tight. All right, so if we were to take the square root of 1, that would equal 1. So another way to say 1 would be the square root of 1, and I could put that on the number line. The square root of 4 is equal to 2. We know it's also negative 2. We're not going to get into the negatives on our number line. But we could write the equivalence of 2 to be square root of 4. So the square root of 9 is equal to 3. The square root of 16 is equal to 4. The square root of 25 is equal to 5. Square root of 36 is equal to 6. The square root of 49 is equal to 7. The square root of 64 is equal to 8. The square root of 81 is equal to 9. The square root of 100 is equal to 10. The square root of 121 is equal to 11. The square root of 144 is equal to 12. The square root of 169 is equal to 13. I'm going quicker now. I probably started off a little too quickly, but I think we know a lot of these, or we're catching on to the pattern at least, right? Okay, we're just going to stop there. Square root of 225 is equal to 15. All right? So I could put all of these numbers on the number line, which means anything that comes in between those consecutive numbers could be a decimal. The square root, if not a perfect square, is a number that is going to go on and on forever and ever. Okay, so do you remember what that's called? Yeah, it's called an irrational number. It cannot be rationalized, and it cannot be written as a fraction. So if I were to say, hey guys, what is the square root of 10? Well, that is not a perfect square. There are no two numbers that you can't, or one number multiplied by itself that gives you 10. But I do see here that if I were to take the square root of 10 and look at it consecutively, let me try to, make this a little bit bigger. Doesn't 10 come between 9 and 16? And it's, again, probably a little bit closer to the square root of 9. It would probably be right about here on the number line, which means that the square root of 10 is probably approximately 3 I don't know. It's very much closer, 3.2, 3.1, somewhere in between there. Okay, so we're just going to estimate, and I'm going to have you estimate with one number after the decimal, okay, to the nearest tenth. We also could say that the square root of 10 is between 3 and 4. Now I'm going to abbreviate between 3 and 4. We definitely know that. Okay, let's try another one. If I said the square root of, 70, what is the square root of 70? Well, it's not a perfect square. It doesn't fall on my list here of my perfect squares. Well, the square root of 70 definitely falls, it's bigger than 64, less than 81, right? Just looking at the numbers consecutively. It's almost, I mean, it's a little bit closer to 64 than 81 in the sense that you add 6 to get to 70, and then you are 11 away from 81. So it's probably right around there. It's not exactly in half. Half would be between, let's see, 6, 7, be a little bit further. So it's close to that. So I would estimate, or we could say, first of all, it's between 8 and 9. We know that for sure. It's between 8 and 9, okay? Now let's estimate. I don't know. It's probably 8.4. I'm just going to guess. Now, if you want to see how close you are, I'm just curious. You can type it into your calculator and see. Oh, it's 8.36. So if we round it, I would be right on that. So it's pretty close. It's a pretty accurate way when you estimate it. All right. Last bit here. On your homework, you are going to need to both identify what numbers it falls between, and then some, just for a couple of them, are you going to need to estimate, okay? Now, there are going to be some that it's exact, like what is the square root of 36? Well, 6, okay? All right, I hope you feel comfortable with all of those things. That's most of your homework. Let's get to one other tidbit of information here, and this is brand new, which is why I'm going to spend a little bit longer on it and not go over some of the other things in as much detail. That should be very much review for you. All right, we recognize this. If I were to take the square root of x squared, if I were to say some number times itself, and then take the square root, it's almost like I'm undoing it, right? If I were to square something and then unsquare it, I would be back to where I started. So if I squared x, and then I took the square root of x, I would just have x. If I took 4 and I squared it and got 16, and then I took the square root of 16, I would be back at 4, all right? Now, when we're dealing with squares, you cannot have a negative square. If you have squared something, there's no way it can be negative. If you have a negative times a negative, right, we did negative 20 times negative 20 and got 400, there's no way for you to multiply two numbers that are the same and get a negative number. You'll either get a negative times a negative, which is a positive, or you'll have a positive times a positive, which is also a positive number, okay? So if you have the square root of some negative number, if there is a negative sign underneath the radical, this is really important. You'll need this on parts of the homework problems. If you see a negative symbol inside, stop and say inside, it is not real. Okay, now this is where we get imaginary numbers, and you're not going to get to this for a couple of years, but you can actually do math with it. However, it's called an imaginary number. Okay, now if the negative sign is outside of the radical, then that's different, because what happens is there are essentially these parentheses, meaning we're going to square and unsquare it first. And so by following the order of operations, I can do that, and then I just take the opposite of it. So if I said negative square root of 4, well, what I need to do first is look here. The square root of 4 is 2, and then I have to take the opposite of 2, because I still haven't used that negative sign, so I just put it there. It's just negative 2. So the opposite of the square root of 169, well, the square root of 169, do you remember what that is? 13, good, but 13 is just my number. I still need to use my negative symbol, so it's a negative 13. Okay, now if I had the square root of negative 169, there is no real answer. Or you can just say not real. The answer is not real, it's an imaginary number. Okay, because I can't take a negative 13 times a negative 13 to get to a negative 169. It's just not equal. And a positive 13, remember, it has to be times itself. Of course, you could have one of each, but you're not squaring it, right? Positive times a positive doesn't give me a negative 169 either. So there's just no way to do it. And if the negative sign is outside, then you can just keep the negative sign to go through with it. Okay, I am going to stop there. Watch this again. If you have some questions, email me, but try these out.